Okay, so here we are in Unreal. We're going to look at materials from here. So this is a continuation of the shader lecture where we were just talking about uh, Unity, and in this case, we're going to be looking at the way Unreal handles materials, and it's very similar. So to start with, we're going to create a material, as here, our material. I suppose I should have called it my material, follow pattern, and then this is our material shader. So if you recall from the Unity lecture, the material is essentially just a wrapper for the shader in Unity, but you do have to pick the shader. So you kind of have a separation. In Unreal, the material and the shader are the same thing, but the notion is identical. So in this case, the fact that our material is a wrapper for the shader is the same. The things that we are getting out of the shader are the same. So in this case, what we're worried about is all of the stuff from our material here. Um, and this is identical to the kinds of things that we were outputting from the surface shader for Unity. This is kind of assuming the normal shader pass. We talked about a number of differences in terms of lambda and specular and so on, but this is assuming like the full PBR pipeline, and therefore we have a bunch of the parameters that we need to set. What's convenient here, of course, is that we actually know by these little input pins which parameters we have available, right? And in Unity, it's not necessarily there with the scripting, although we're going to take a look at the Unity shader graph, which is going to be closer to that. All right, so let's get into it. So to start with, if you've kind of forgotten this about Unreal, uh, everything we're doing is with visual editing, right? It is possible to do some scripting or some C code and some scripting, in fact, too. Uh, but for the most part, and especially with the shaders, it makes a lot of sense just to use the graphical system because it's a sort of a graphical context you're playing in, and having it that dynamic is pretty nice to work with. So what we're going to do is we're going to pull a pin off of here, and this is going to be very similar to the Unity style, where we want a texture sampler or sample parameter. And so this is a little bit like what we saw with Unity, where we're placing a texture at the top, a parameter that associates with our texture. We'll give it a name like, albedo or maybe main texture. And that really does mean our albedo in this case. I'm going to use a different default texture here, so this one's a little weird looking. If you've, and this is an empty project, but it does have the starter content. So if you bring in the starter content, then you get this cobblestone texture, which is great to play with, especially since it has sort of some great features to play with in terms of texturing, and we'll look at how we can play with those features. And this is doing the entire UV mapping for us, right? So this again is we're really just repeating the same structure that we did with the Unity default shader, where all we did was define a main texture at the top, and then in the surface shader piece we said go look up that texture, which is really what's happening here. It says go look up that texture, look up the color according to the UVs, and in this case the UVs are the default set that are associated with that model. We can also specify which ones we want, so we can say text coord, and we'll get the 0 coordinate. Potentially we could get other coordinates if we knew our model had those and we wanted to try to access those. We're just going to worry about text coordinate 0. So this is, I've gone in, I've unwrapped my model, and I've set up a set of texture coordinates, and now I'm going to use and play with those texture coordinates, right, to lay things out. Okay, so next I want to look at a few things here, just the pieces, the parameters that we kind of seen before, but in a new light. So let's actually change this texture. We're going to make it white, so it's very, very similar to then the Unity that we were seeing before. And in this case, I'm going to bring out, let's do the red. And what I want to look at is both how we set various parameters to control our metalness or specular. So we saw things like glossiness, or actually I don't remember the other variable name for Unity, but there were variable names there. And again, we were worried about whether or not they were floats or sorry, they were vectors or single values. And so the difference between a vector and a single value here is known as a scalar. And this is a mathematical term, which just means it does not have a vector form. So it's either vector or scalar. And so most of the time, that's what you'll see here again. Even the texture 2D is really a vector parameter. It's a 2D parameter. Here, the scalar parameter lets us set a single floating point value from 0 to 1, or, well, 0 to anything. But again, we kind of just care about it being 0 to 1. And again, this is, the metalness. We'll go ahead and pull out our specularity too, which is a little bit different than unity here. And we'll also look at the roughness, and you recall that the roughness in this case, again, is that micro roughness, right? So the sort of microscopic scale, picking between, and I said earlier, lambda versus specular, or versus Phong. It's really Lambertian versus Phong, or versus specular style highlights. Okay, so I noticed something before I get too much further here, that my attempt to pull the red out into the base color is not actually working. So the problem is that I'm passing in what is essentially a scalar value, a single parameter, or single value, single float value instead of a vector, and the shader is actually auto-promoting that to a vector by essentially copying the components. And so we're sort of getting the white color back again because it's taking the red and almost treating it like we said red, red, red instead of red, green, blue. But because we know what the red value is, we're going to get a grayscale. So let's do this. Let's say make float 3. And then what's going to happen here is we're essentially putting the red back into the first component. And then the y and the z are going to get set to 0. Now we could, of course, do this, and suddenly we have like a, what is it, yellow, that's right. Or we could make ourselves a purple by playing around with these, pulling in the pieces. And of course we could also screw around, with other colors if we really wanted to, and change the red and the blue. But in this case, because we're starting with white, which is 1, 1, 1, swapping them doesn't matter. But I kind of want to look at what happens when we change these parameters for different things. So it's a little interesting. And I've also changed the shape here between the cuts. We even have a shape for oh, I guess I don't have a base mesh to play with. We have a couple shapes to work with to just see the way our texture works, which can be especially really useful when you're doing some interesting shape textures. In this case, I just kind of want to look at the way the light is playing with this texture. So we can see things like, if we change the roughness, so it's rougher or not rougher. I can't say that I'm noticing a big difference when I change those. I'm not sure why, but it may just depend on the parameter we're playing with. The metalness is one that is pretty obviously changing. So if I set that to 1, then it's a highly reflective surface, although it's a red and reflective surface in this case. But again, we're seeing the surrounding environment, right? And so we're seeing the full reflection. If I make it a sphere, then we really get to see exactly what's reflected, because the sphere is pretty good. And just for fun, if we make it be a white, you see it's exactly reflective. And this again comes back to the idea that the white albedo means it's not absorbing any color, right? And so it's sort of fully reflective of the color of the entire thing. And so we're really just getting all of our colors right back to us, right-handed back to us. If we were to pass black in here, we would get nothing back. So a black metallic surface is actually still going to be non-reflective, right? So and there really isn't. If I haven't said this before, I'll say it now. There really isn't such a thing as a perfectly black or a perfectly white surface, except pretty much in video games, where you're going to see that kind of thing. So yeah, so the metalness here, much like it was before, it's really about the reflectivity or just how much is absorbed. And I tend to think of it as metalness is. I don't know what the underlying math is for this, but I tend to think of that as the hardness or just the principle of the photons being reflected back out, right? They can't be absorbed by the material for whatever reason, and we assign that a property of metalness. The underlying math in this case doesn't matter so much as long as we understand how to use it and we can play with values. And again, the specular, for whatever reason, doesn't change. And I guess it does change in this case a little bit. We can see some reflectivity. Um, so it's a little bit different than metal reflection with a smooth surface, but it's not. Yeah, it's a little bit different than what we were seeing in Unity. So my recommendation in this case is always to play around with the parameters. Never go from 1 to 0 in many cases. Figure out what it is you're looking at. Try to get a sense for how it works. Because you're probably not going to know the math all the time, and so it's much easier if you can go in and understand. You start with the 0, start with the 1, start with the 0.5, and get a sense for everything in between. You might find that you get down to the levels of detail where you're actually trying to do 0.25 or 0.2 or even 0.01873 or something. It might also be that you just pulled a parameter like this and you came up with one of those magical numbers, and it's not really something that came out of your head or that anybody thinks it's 0.1875, but you will see those kinds of things. And that's fine because they tend to work pretty well. We'll actually see one in here in a little bit because I had a case where it's actually useful to go into the lower level digits. All right, so those are the parameters we're dealing with. Again, they're very similar in style to the Unity parameters, other than this difference between metalness and specularness. We didn't really get into emissive, but we're not going to worry about it here either. So moving on, let's get back to our proper cobblestone. I'm just going to look it up here. And I want to pull in not just the cobble, but it's normal and actually it's metalness as well. Putting a name in before I do it. So this one does have, so usually these things are named in some way that makes sense. And well, the M here is maybe not metalness. I'm going to use it that way anyway. It's actually a grayscale image, which probably represents the height, but we can also use it for its reflectivity for some of these surfaces. And then the last one, of course, is the normal. And we don't have to do anything special here because Unity needs to know that we're going to decode a normal. Unreal kind of knows it for us, right? So it's actually set the sampler as normal here. We can actually look at a number of samplers that are pulled out. I'm not going to really look at those. We might get back into talking about linear versus gamma later, but at least for now, the only two we really care about are either we're pulling the color or we're pulling the normal, just like we did in Unity. And just to compare, because it's actually pretty easy to do, let's pull the normal off of the band off of there and make sure we can see what our normal is doing and what value we get out of that, especially in terms of light. Probably a little bit hard to tell for sure. But yeah, that's getting to at least the sort of standard setup. So this one's kind of fun because I don't know a function that does this offset as well as Unreal does. So in the first semester, the intro semester, I talked about some what we refer to as parallax mapping or parallax occlusion. And there's a very complicated shader for doing that. I will set that up toward the end here just so you can see how that looks. But there's actually a simpler one which is available called the bump offset. And what this does is essentially do the full parallax offset, but doesn't necessarily do the parallax occlusion. And we can look at a little bit of what that means in a minute in terms of the way things get hidden. But the parallax offset is pretty good. So what's happening is that we're actually shifting based on the height the texture coordinate lookup. So we're going to put our coordinates in here as our coordinate that we're going to read from. And our height, I'm going to copy this parameter over here, right? And so what it's going to do is shift all of our offsets. Actually, I'm going to create a separate sampler, that way I can have all of these guys use the same one. And the height here is meant to be a bump map, so it has to be a grayscale color that represents our height, right? So again, you know, we looked at the fact that the normal is a derivative of the height, and that we can get back to it that way. This we're actually going to use the sort of grayscale here as our height. And in this case, we might actually be, the height is really a scalar value, and so this is getting where we were sort of promoting it from scalar to vector before by passing it in. Now we're demoting this scalar by just taking the first value. So we're only taking the R value out of this. We could also just pass in the R value directly and make it more explicit without any change. Of course, we're not actually changing anything here because we're not using it. And so given that, we see what might look like some height, right? So we see the actual texture. Take a look at this rock as I rotate. We'll see this texture turn and shift, and that represents, you know, it gives you a sense that you are seeing height here that is not actually there. And this one's pretty good. This one's cheaper than the parallax occlusion map, which I'll show you a little bit later, and which I set up last semester. This one is a little bit new to me, and so it's nice to have. This is what we refer to as kind of standard parallax mapping, and you'll see the same kind of thing in Unity, although you will also often see a ringing effect that can happen. So we want to set all of our parameters that way. That way, you know, everybody's keyed in. Our normals are offset. Our main texture is offset. Everybody's happy with each other. Again, you know, it looks really great from the front end, and it looks like you have a whole lot more polygons than you do, because of course we have very few polygons here. And I think let's see, yeah, we can show the wireframe. I mean, actually, I guess we have quite a few polygons, but there's not as many as it would appear to be in order to get this kind of curvature on the shape. And it's really great. This is a great effect, but of course it's limited. And if you look at it from a really oblique angle, then it doesn't work so well. Often this kind of thing is used for, say, a terrain or a street, because if you were walking along the street, you would have an angle like this, and you might actually get a sense that, you know, there's cobblestones there. And, so you might even believe that you have 3D, because you probably won't ever be in a game in that sense where you're going to get in from the angle like this, right, where you're just seeing completely flat. Okay, so that one's pretty cool. But before we get into the full parallax occlusion map, let's do something even more fun in this case. So what I'd like to do is use the height to blend between two textures. And so we also have a grass texture that we could use. And what I want to do is, when I'm in sort of this gutter area of the texture, sort of the low height area, I want to show the grass texture. And when I am, you know, in the rocks, then the rocks will come through. So rather than whatever texture is here, I essentially want to replace the texture that's in the ground. So to do that, I'm going to bring in a few more. I'm going to start with the grass color. In fact, I'm just going to leave it with grass color for now, because we don't have the height offset. Of course, it doesn't necessarily mean anything. And what I'm going to do with this is take this R value and essentially round it, right? And so by rounding it, what happens is, if it's greater than 0.5, then it becomes 1. And if it's less than 0.5, then it becomes 0, right? As you know, you might expect. And what I'm going to do is add or multiply this. I'm typing this star character, but you could also type multiply. I'm going to multiply this one by the round, and then this one's really cool. I'm going to do minus, and 1 minus is a standard operation within a shader. So this kind of thing is so common that it already has a special feature, right? So there's a lot of shader things like that. So sine is another one of those that you get almost for free inside a shader, and it's pretty cool. Even though we talked about dot products and the fact that dot products are still cheaper. In fact, dot products are still a lot cheaper in a shader and on the GPU. But things like 1 minus, saturate, and so on are all free operations. Saturate means that if you have something that's greater than 1, it sets it to 1. If it's less than 0, it sets it to 0. So make sure that everything is between 0 and 1. Because a lot of these parameters, we really care that they stay between 0 and 1. And so in a lot of cases, we can just do a saturate very cheaply. Okay, so what you get whenever you try to do this sort of standard blend, and this is a really standard blend, we do 1 times something and then 1 minus, or sorry, the value times something, and then 1 minus that same value times something else. We add them together, and this is pretty much a standard blend type operation. And so as we change whatever this is, we get a potential blend. In fact, we'll look at how that looks if we operate it out. Okay, so we've got our grass, and the grass is kind of high, right? So maybe we want to blend a little bit differently. And so what we could do is here, rather than a height-based blend, let's just look at what it looks like if we change this to, say, just any constant. So rather than a scalar parameter, I'm just going to bring a constant in, which a constant means that it's a parameter that won't be exposed externally. So I can say, well, 0 means that I'm really just getting at this point, well, I'm still getting the normal values. We'll fix that in a minute. But I'm no longer getting any color from there. I say 0.5, then now I'm getting sort of half and half between the two, and if I go all the way to 1, then I get the entire cobblestone texture again. So that's a sort of standard blend, right? We could go somewhere in between. We could say, it's mostly the cobblestone, but kind of some grass too, and that looks close to what we want. But it's like grassy rocks, right? We don't actually want grassy rocks. What we want is a hard edge, and what I want to do is play with where that edge comes in. And so what I'm going to do is add in a constant value here. And so the adder lets us set a constant on the second value. So if I set it to 1, that's not so great. In fact, I'm going to go ahead and saturate for the sake of this, because now the round will actually let me go a little bit too high, right? So if it's 1.5, it'll let me round it up to 1.5. So by saturating, I get back to 1 to 0, right? Okay, so I'm adding in 1. Let's add in like 0.2. So now what this means is anything sort of 0.3 and below is going to get added in. So that's maybe a little bit too much. Let's try 0.1. And so now anything that is 0.4 below gets added in, and that's pretty good, right? So I'm going to say 0.07. So here's where we're starting to play with parameters that we might actually get low enough that we're playing with. And one of the strategies I would use is go by half every time, right? So we found 0.1 works. So let's try 0.05. And we like 0.05. Add, that's okay. I think I might do 0.025. So I'm going to have it again, right? Or I might do 0.075 if I want it to be a little higher. Actually, in this case, I'm going to go, I am going to go higher, I think. Yeah, I'm forgetting which direction I need to go. So the higher the number, the more of the grass shows in. I mean, the more of the cobble underneath. So 0.1 was kind of good. Yeah, I actually want to do 0.5. I mean, I'm going the wrong direction. Yeah, there we go. And now I'll do maybe 0.75. So the higher this number, the less grass we have, right? That's the thing that I'm forgetting. So kind of like that. Maybe I'll do 1.6 at this point. So I'm going to start playing with the numbers a little bit lower. But yeah, I kind of like this. So I might do it. I don't know, do something like that. Okay, I'm not going to play with it too much longer. But you get the idea. So it's actually pretty straightforward to set up the kind of thing that looks cool here, right? We want to replace our base texture, or even if we want to blend between, our rock pattern, if we were on, say, terrain tile, and we wanted a better blend between this kind of rocky pattern and our grass texture, as we're moving from grass into rock, we could do something like this to actually represent that blend, rather than having to go straight from rock, doing this sort of linear blend that we were just looking at, right, with changing the value down here without rounding it, without caring about the height necessarily. So this is pretty cool, but let's take it one notch more complicated and bring in the full thing. I'm going to not pause the video. I'm going to go ahead and bring in the normal that promised. So let's do a texture sample here. So these blends, again, try to remember that we're multiplying by colors, but it's all just 0 to 1, and you can think of it as probability if that helps. We're multiplying 0.5 probability times 0.5 probability and getting 0.025 or whatever. But in the end, yeah, a lot of this stuff, still kind of makes sense. So hopefully, we kind of want to keep things 0 to 1. That's where thinking about it as probability helps. But we can multiply these as though they're a vector and still get values back that make sense. We can add them together and still get values back that make sense. So we can do that with the normals too. So we're going to do that here by finding the grass normal again. We just do exactly the same blend. So I'm going to just copy these guys. Hit Control C, Control V, and this one is our A. Oops, this was our A value actually. So we want to take the saturate down here, the saturate down here, and then our normal over here is our A value. And now the add goes here. Now you might, have some concern about the use of like specular and metalness for each of these. You might actually blend them and choose, the metalness value that you care about for the grass. In this case, I'm kind of fine with, I'll just make it all, it's sort of 0 metalness. It's all pretty rough, I think, right? Yeah, I've got a value of 1 there. My specular is around, 0. 0 is probably good. So the rocks and the grass are both not very reflective, right? And so we've got everything blended the way we want. Might tweak that a little bit more and put a little more grass into it. But yeah, okay, so we've got that. So parallax occlusion mapping, as far as I recall, is really a raycast. So where I said the and it's hard to find some of the information on this. It depends on where you're looking. The standard parallax simply moves relative to the view the UVs more if you're higher and less if you're lower, right? And so what happens is that kind of shifting that we were seeing over here. If we look at one of these, it looks a little better if we're looking at the sphere. So if we look at like the rocks as we're rotating, we actually see the higher parts of the rock shift, right? So the texture moves as we're rotating. But that isn't the whole story, right? And so what should happen is if you are far enough along, this part of the texture should actually start to occlude over here, and what you will end up with is something that looks even more 3D like, right? And so it does a raycast and it tries to determine where it should be occluding, who it should be overwriting, and so it shifts those underneath. And so it's a very complicated process. It's a very, very expensive shader, but it looks pretty cool when you put it together. And so what's going to happen is we're going to modify this bump offset with all of this stuff over here. And so because I don't really understand everything that's going on here, and I've found a few tutorials online to describe how you go about setting this up, most of this is kind of hidden under, under it a little bit. I'm not sure what the difference in terms of Unity's parallax mapping versus this parallax mapping, but this is the full thing, the full story. So it's cool that we have access to it. This one's pretty hard to play with. It's very hard to find documentation on. In fact, even the place I found the original documentation has gone away, so I'm going to reuse my old notes, my old copy of this, and we're really going to punch in exactly these same numbers because I know they work. And so that's kind of where we're sitting with this. But I want to kind of show you what it looks like when you go to the full extreme, because it looks really good in Unreal, and it's hard to get this level of quality without going into the details and trying to understand all of this in Unity. And of course, you can potentially write this in Unity, but you don't get it out of the box. And so let's take advantage of it while we can. So I'm going to create that parallax occlusion mapping node. I'm going to set it all up. And really, the only difference is that, you know, we've got this bump offset and it's fixing our coordinates. We're just going to use that same set of coordinates down here, right? And that's going to set it up for us. But it's worth remembering that what we're getting out of this is extremely expensive. Oops, that's my record. Make sure I'm recording. Good. And so it's not something you want to do all the time. I'm not sure I have a good case for when you might use it, but oh, I think I need a texture object. I'm not sure what the difference is, quite honestly, but let's just get that. Yeah, so but of course, we'll talk about optimization, and when we get into optimization, we will, I keep clicking the wrong thing. As we get into optimization, we will talk about like the kinds of things that you optimize. And the first thing, of course, and then I will say this again when we get into it, is that you need to measure. You can't optimize what you can't measure. I'm actually going to copy that value. I don't know where that value came from. I think I may have played with that number to get to something. But there's one of those fun magic numbers you can get to. I think I recall the number of steps is 8 and 32, right? Okay. This lerp parameter pretty much does the blend that we did before, so we could use that as well. So there's one minus operation that I showed you. We did multiply, so this pretty much takes, you know, whatever parameter I'm passing in here, whatever parameter I'm passing to A. In this case, it's only a float lerp, and so it's really just those two values, whatever A and B are as scalar parameters. See, here's an example of a vector parameter, actually. So a vector parameter is always a color in this case. And again, because we only really care about whether or not we're doing scalar or not scalar. So append vector in this case means that we're going to take these two values and turn them into a two vector. We specify manual texture size as a Boolean. All right. We'll do that as a static Boolean parameter. So a static parameter in this case means that it's the same across all instances. All right, so the grand finale here, let me walk through it here and where we have our current setup. Again, we have sort of our grass in between. We have I'm actually going to add that a little bit lower. I just want a little more grass so we can see the effect a little stronger. Okay, so we have more grass here. Oops, let's wait till it adjusts. And we, you know, get some sense of depth. But let's look what happens when we actually connect up these UVs. So I've still got these UVs down here. Finished through the process. Again, it's sort of a rote. Let's just use some values that work pretty well. The one that you can change is the height ratio. In fact, you can change the height ratio down here as well. And that gives you like a stronger or less strong effect. In fact, let's go ahead and plug it in just so we're even. So I think that's going to make it a little, yeah, that's going to make it a little stronger. So let's go ahead and actually, let's bring that number down. Oops, to something we can deal with. Yeah, that is probably too low. Okay, that feels okay. We're doing a little bit of a pretty heavy skew here, but it's not too bad. I think actually if we don't set anything, our default is probably something like 1, but that's okay. Okay, so let's take a look at the difference. So really, what this is doing is, again, changing the UVs, but it's changing the UVs in a lot of cases, all based on this height map input. Much more expensive, but really kind of a similar process to what's happening down here. A lot of the same kind of stuff, but this gives us a lot more control over the number of steps that we're iterating through, the number of raycasts that we're doing to figure out when we are seeing something or not, and all to make things disappear when they should disappear. So I'm probably going to do this once and not go back and forth, so you can fast forward and rewind in the video to look at the difference between these two. So I'm going to go through what we're seeing over here and compare. Oh, let's see. Oh, that's right. I need to make this input. So you see some weird stuff over there. Oops. Some weird stuff over there with the where the grass was working. That's because my actual blend map, my offset that I'm using over here, was not plugged in, and so because that was not plugged in, then it was using the wrong offset. Let's see what that bug looks like. It's kind of fun to see. It actually looks like the grass is hovering. That's because the grass is using a different offset. So although we're kind of using the offset texture, we're not actually blending at the right time with the grass, and so we're kind of overlapping in a weird way. But because now everybody's using the same set of UVs to decide both when we should draw grass and when we shouldn't draw grass, now they're laying together. And what you see is, as we get to the edge over here, things like this very large piece will actually cover over the grass. And that doesn't really happen, right? This is the occlusion part of the occlusion mapping. And so that gives you an almost real 3D effect, right? Entirely based off this bump map texture, this one over here, to decide that. And so it's a pretty cool effect, but it is doing this essentially what is happening 32 times, give or take, or up to 32 times per picture, or per pixel, per fragment. So it's doing a lot of work. Like, remember, this is much like the surface shader. This is after we've already gone through and we figured out where our vertices are, how we're projecting the space, how we're doing the clip space. This is all the linear interpolation piece, right, as we're doing the texturing along that triangle. Now, I won't bring that slide up again, but I'll ask you to review if you forget. So this is a lot of work to do per pixel. And when we talk about optimization, one of the things that we run into is fill rate problems, which is how much compute you're having to do for every pixel on the screen. And in some cases, if you overwrite the pixels many times, especially in semi-transparent cases, or you've got the depth mask wrong, then you end up with a heavy fill. And we'll talk about when we get to optimization. I'm not going to start planning that lecture quite in the middle of an existing lecture. But yeah, so this is pretty cool. This is about as good an effect as you can get out of a texture, with a lot of faked effects. This is probably the biggest texture effect I know of. Let's look at it as a cube too, just so we can see that. But it's one that you need to use carefully, or at least you need to make sure you do it. So again, if you decide to go through this process yourself, I recommend trying it out just to see, especially because then you can play with it by remapping it. But go compare. I've had parts of the video showing this with just the bump offset, which is pretty good. Gives you some pseudo 3D, but this is a lot more 3D, right? So you can actually see that occlusion that's happening there, and you won't see that with the bump offset. All right, so that kind of covers a whole lot of complex texturing effects that we can do here. And we'll go back and look at the shader graph for Unity and compare and contrast. Hopefully, those of you who are programmers can take a look at some of these. Maybe the bump offset is not so clear as to how you would implement that in Unity, but a lot of these things, just getting this height-based blend, it's actually pretty doable in Unity with a little bit of thinking and work, and you can do the same kind of effect. I'm not going to walk through that, but I will leave that as an exercise to you who want to play with that. So let's go through the last little bit here. Let's look at the Unity shader graph. So to do that, we need to create the well, either the high definition render pipeline or universal. We'll just do high definition because the shader graph only exists here. This is the one reason you might use caution when doing this, because the high definition pipeline is new. And we will go over it, but it is quite a bit different than the standard pipeline. And so if you're used to using Unity, it could be a significant change for your project. So use this with caution if you're going to move this way. Okay, so I did skip ahead here because it's not interesting to watch load screens. We are looking at the default view from the high definition render pipeline. I'm going to create a new scene just to play with that. I'll create a sphere. So again, we'll kind of talk about the pipeline a little bit later. For now, I'm just going to set up a global volume and put an exposure on it. That way we can look at this if we want to. I'm not sure that we're going to care so much about it because we're going to pretty much live in the shader graph, but just in case, I'm going to create this sphere, and then we can put an object on top of it. So as usual, we are going to create a new material. So we'll have our test material here. And then we are also going to create a shader, but we're going to create a new kind of shader. So if we look over here, oh, right there, under PBR graph, so remember PBR, photo-based rendering or physically based rendering is the name of the game here. That's kind of the full pipeline that we're using. There's a few other options, of course. But, you know, we'll go into those later. But let's just look at the PBR graph for now, because that's the one that's going to be most familiar to what we're looking at. And so, let's see, test shader graph. Yeah, I don't know that we'll actually get into the other types in this class, but at least we know they exist. We might talk about that later if we have some time. So when I double-click this graph, instead of getting a text editor, I end up with something that looks sort of like what we saw with Unreal, except that this time we're in Unity, and we also get a lot of interesting defaults here, right? That actually set up our sphere. This is mostly a non-interactable sphere, although we can do a lot of the same kinds of things that we're used to within Unity that we did within Unreal. But we see, you know, we're trying to set albedo, normal, emission, metallic, so on. So a lot of the same features exist here. Now I'm going to bring in some textures so that we can kind of look at repeating what we've already done, except this time within the shader graph. Okay, so I have some textures over here, some cobblestones. These are not the same cobblestones that are in Unreal. They're a different set from some source online. But I will create a color node so we can start seeing our usual. Things will start to look very similar, right? So we're going to do a sample texture. Rather than setting the parameter down here or wherever else we might have set it, we'll just go find the base color and then assign that base color to the albedo. Right, and so now once the shader compiles, and of course this is a little bit newer and exciting, I think, in this case, that we are now having to wait for shaders to recompile every time we do a modification here. But we can do, so there's two shortcuts. One is we can right-click to bring up this create node, or we can just hit the space bar and do the same kind of thing that we do within Unreal to pull these things in. So I'm going to double check that this, so if you have not dealt with the Unity asset pipeline, or if we have not already talked about it, when you bring in a texture, you do have to specify that it's a normal map so that it knows to process it differently in terms of the way the assets work. If then we bring in a normal, we also need to make sure that we change the type over here. So a little bit of that is less automatic than we were finding in Unreal when we looked at that. But given all of that, then we can use our normals as before. And now, once those are up, we get those. So there's a couple other pieces of texture here. I think we've talked enough about ambient inclusion that I will not speak to it more, but this is self-shadowing. So this particular texture asset has that. We can use it. It goes into the inclusion here. It's ambient occlusion, and so it's essentially a rendering with a full sphere or a hemisphere around, in this case, probably the plane, and then it's using the heights of the cobbles to determine whether there's shadows. So you can see there's some deep shadows in some of these places versus the places that are higher up. In some ways, it's very similar to the height field, except that, you know, of course, it's not really reflecting the height, it's reflecting the full color. But that adds a lot of great lighting cues just by virtue of the fact that it is adding lights and shadows, assuming, you know, full lighting, and so that tends to translate well into the environment when you do that kind of thing. I'm going to set the smoothness to 0 on this guy because, again, it's cobblestones and those are usually very rough, and of course they're probably not metallic. And then the final texture we have is a height map. So once again, we can go in and use the parallax offset map. And so we're going to see a little bit, this one's much easier to set up. Do the spacebar version. But it's not, but it doesn't look quite as nice as the way Unreal's work when it's actually going. It takes a lot more to set it up. Oh, I got a roughness patch there. I guess I can plug that into roughness. Let me do that real quick. I forgot we had a roughness over here. Rather than using this roughness, I will just bring it over. Oops. Again, it's a grayscale, so it doesn't matter. Some of these, because they are grayscale, we could actually put them, combine them into a single texture so that we're not having to read two different texture passes in order to bring these textures in. We could actually combine them into a single texture. What you'll notice here is, so this is an interesting point to bring up, I think. So I've got my roughness here, but what I'm getting from Unity, or what I need to put into Unity, is smoothness, and so I'm actually getting the wrong value, so my rock's a little bit smoother. If we look up our friend minus, we find that 1 minus is also here. Now, what I find kind of fun about Unity's output here versus what we were seeing in Unreal is that we can actually see a byproduct of the operation that we're doing. So in this case, because I'm subtracting from a texture, it's actually giving me the texture output on a per pixel basis for this operation. So it's doing 1 minus whatever the texture value is here, and then we're producing a texture along those lines. And then if we plug that in to our smoothness, and once we wait for it to compile, we see that we do get the kind of roughness that we were expecting. Okay, so the last little bit we'll cover here with the textures is just to take a look at our friend, the parallax occlusion map, just to see, you know, how it compares in Unity, how we feel about using it here. So it's available. I find it a little bit more difficult to work with, I have to admit. It doesn't look quite as distinctive as Unreal's version, but a lot of the factors involved are very similar, except that it's much easier to set up. So, you know, in this case, if I want to do the 32 steps for iterating over it and change the height scale, I can do that, and we see, you know, the similar kinds of things. In fact, I might use like a 3 or something to get a significant feel out of the height. But there's some weird artifacts that show up, you know, depending on which one you're looking at. Maybe some of these feel a little better than others. The cylinder, you get some decent height out of this guy right here, right? Where that particular cobblestone has some good height to it, and so it actually comes through pretty strongly. But yeah, we have the same sort of feel as all of them. Does a little bit of weird stuff at the top here. But yeah, I guess at this point you can start, playing with the shader graph if you desire. And we will probably have some lectures later on about the full render pipeline. And there's a lot of opportunity to play with the render pipeline. So, again, we're kind of looking at the standard PBR here, but there were quite a few other shaders. And really, when you're dealing with the render pipeline and customizing that to a larger extent, you are customizing a lot more of the system. And so there's probably a lot more power available when we get into the weeds there, assuming we get the chance to look at that. In terms of versus Unreal and what we can pull off there in terms of what we're modifying with shaders. But it depends on what you're looking at. So we'll kind of take a look at that potentially later on. But for now, we'll put a wrap on shaders. Hopefully this is enough to kind of get you moving forward and asking some interesting questions about things you want to render. But I look forward to hearing your questions on Friday on any of this stuff. So talk to you then.